Here's an example of solving a basic trigonometric equation that has sine in it. So our equation is 4 sine theta minus 2 times root 2 equals 0. And since we're solving an equation, we have to be sure to find all solutions, not just one solution. Let's start by isolating this theta. So we can add 2 root 2 to both sides. And that's going to give us 4 sine theta equals 2 root 2. And then divide both sides by 4. And we get sine theta equals, can cancel a factor of 2 here, root 2 over 2. Okay, so really we're going to solve the equation sine theta equals root 2 over 2. And let's start out by drawing a picture of this equation. I'm going to draw the most important diagram because that's all I know how to do. So here's a unit circle, and 2 root 2 is, it's about 0.8. And since we're using sine, we should treat this as a y-coordinate, so up here. So we need to figure out all possible angles that put us on this y-coordinate. Well, you probably, since 2 root 2 is, I'm sorry, I've made a horrible mistake. 2 root 2 is not about 0.8, it's about 0.7. So I should move this down a little bit, more like this. Okay. All right, so 2 root 2 is a pretty familiar value of sine, so you probably know an angle right off the top of your head that has a sine of 2 root 2, and it's pi over 4. And sure enough, pi over 4 puts us on this y-coordinate, so there's pi over 4. So there's one solution, but we can add any multiple of the period of sine because that won't change the result of sine. So we can add 2 pi k, and keep in mind that this k here can be any integer, even negative. Okay? But looking at our most important diagram, there's another terminal side for an angle that would put us at this y-coordinate. It's right here, this yellow one. So what angle is this? Well, because root 2 over 2 is such a familiar output for sine, you can probably just come up with this angle off the top of your head. But let's think about the symmetry of sine. Now, the symmetry of this picture is such that this left-hand wedge between the negative y-axis and the yellow terminal side, that's the same size as the green wedge on the right. So these two green arcs are the same angle. And that means that the big yellow arc here is a half turn, which is pi, minus the green angle that we found at first, and that's pi over 4. And so that big yellow angle is 3 pi over 4. Okay, so this solution that we found from symmetry, it's 3 pi over 4. And of course, we can add any multiple of the period of sine, so plus 2 pi k. Okay, and the thing to remember here is that this symmetric solution, 3 pi over 4, this was pi minus our original solution, pi over 4. This original solution I usually call the principal solution. So for sine, the symmetric solution is pi minus the principal solution. Okay, that is different from cosine. For cosine, the symmetric solution was just the negative of the principal solution. But for sine, it's pi minus the principal solution. So here we have a very large collection of solutions to this equation. To make sure that we've found them all, let's look at the graph of sine. Looks something like this. And 2 root 2 is about here, say. This first positive intersection, That's pi over 4, so we got that one. And if we go forward a period, well, we did, since we added 2 pi k, we have taken care of this one that's forward a period and the solution that is back 1 period. All right? And 3 pi over 4, that's this second positive solution, so we got that one. And by adding 2 pi k, we've taken care of this previous one on the left. And there's also, of course, another one on the right, just outside of the part of the graph that I've drawn. And there are infinitely many more to the right and to the left. But if you look at this portion of the graph, which is more than one cycle of sine, we did get all of the solutions in this portion of the graph. Since we've added periods, we can be assured that all of the other cycles of sine are also taken care of.